Hi, my name is Abby.
Hi, I'm Christine.
I'm Melissa.
And I'm Mina.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill
T minus 7 seconds.
Bill Nye the Science Guy.
In this episode, you will be learning about the basic principles of chemistry.
Wait, Abby, what is chemistry?
That's a good question, Christine. Chemistry is the study of substances and the changes they go through.
I changed into my pajamas last night. Is that chemistry?
Not quite, Christine.
You see, change can either be physical or chemical. Physical changes do not change what the substance is. For example, if I cut this piece of paper up, I am creating a physical change.
Nuh-uh, the paper is a different substance. Instead of big pieces, they're all little pieces of paper now.
That's right, but the big and little pieces are all still paper. They are still chemically the same substance.
Oh, I see.
However, if I light this piece of paper on fire, the paper burns and turns into ash. This is a chemical change.
So chemical changes occur when the substance itself changes?
Correct! Chemical changes usually appear with a color change in heat, gas emission, or light emission.
I have a test for all of you. When I light a candle, is there a chemical or a physical change?
Chemical.
Physical!
Well, actually, this is both a chemical and physical change. The wick is burning, thus there is a chemical change, but the melting wax is a physical change. Now, when Melissa adds some food coloring to this beaker of water, what type of change is happening?
Chemical change. The water turned from clear to a blue color.
That is absolutely true. However, if I take a sip out of the beaker, it is still water. The substance did not change other than the addition of food coloring. Thus, it is a physical change.
Okay, this is all really interesting, but when can we see some explosions?
We can do one right now!
Rad, dog!
You can all do this experiment at home. All you need is some vinegar and baking soda.
But before you do any chemical experiment, always make sure you have the proper safety equipment prepared. Wear goggles at all times and be extra cautious when handling chemicals.
We put on our goggles. Now can we see the explosion?
You sure can, Crystal.
It's Christine.
Watch what happens when I pour this baking soda into a glass of vinegar.
Whoa! That kind of looks like the foam on my dad's beer.
That's a good observation, Christine. The mixture begins foaming like beer because it is made of the same chemical components.
When the reactants, baking soda and vinegar, are mixed together, carbon dioxide is given off as a product. You can tell by the bubbles that form. Carbon dioxide gas is put into drinks to make them fizzy, like pop or sparkling water.
Ah, that hits the spot.
Because a new product was formed from the old substances, a chemical change took place.
That was pretty cool, but I have an awesomer experiment, guys.
Oh, okay.
I brought with me today my lucky candle.
Christine, we've already shown lighting a candle.
But Melissa, this is my lucky candle. It is no ordinary cylinder of wax.
How so?
Watch as I light this candle.
I mean, it looks pretty ordinary to me.
Hold on, it will happen. See, look. No! What are you doing?
that?
It's actually a potato. See, I have shown you the importance of observation in chemistry.
Christine, that is a very good point. When conducting experiments, you should constantly be making both quantitative and qualitative observations.
Do you want to build a snowman?
Christine, are you crazy? Of course not. It's freezing outside and I don't want to freeze my fingers off.
But guys, snow is so much fun.
But it's so cold. Don't you ever wish there was a way that snow could be made so it wasn't as cold?
But wait a second, there is! Did you know there's a way to make snow instantly?
What?
Yeah, Christine's right. All you need is a chemical called sodium polyacrylate and a glass of regular water. In fact, we can show you all you need right now. Here we have a cup filled with sodium polyacrylate. By just adding water, it will turn into snow.
Wow, look at this.
Okay, that's pretty neat. But real snow is still cooler. It melts into water, evaporates and turns into clouds, and eventually condenses and turns into snow again. It's a never-ending cycle.
Actually, this experiment can be repeated multiple times as well. To reverse this effect, all you need is to add salt.
Wow, look at this. Is this a chemical or a physical change?
Surprisingly, this is a physical change. Sodium polyacrylate is something called a super absorbent polymer. Can anyone think of anything else that is able to absorb liquids really well? Here's a hint. Babies use it all the time.
Diapers?
That's right. Sodium polyacrylate is found in diapers.
When water is added, the sodium polyacrylate absorbs water and can expand to 200 or 300 times its original size.
But Mina, the fake snow feels cold. Doesn't a change in temperature mean that this is a chemical reaction?
Usually, yes, but in this case, the sodium polyacrylate absorbs so much cold water that the snow feels cold to the touch. This is one spot where you have to be careful in separating physical and chemical changes.
So this is a physical change because the actual substance itself, sodium polyacrylate, is not turning into any other chemical substance, but only absorbing water in a process called osmosis. When salt is added, the polymers are destroyed and water is released. This change might look impressive, but it is only sodium polyacrylate absorbing and releasing water.
And just about anyone can try this experiment at home. All you need to do is cut open a normal diaper, remove the polymer inside, and add water.
But remember, although sodium polyacrylate is non-toxic, always get parents' consent and help, and never touch your eyes or mouth when handling chemicals.
I guess the cold never bothered me anyway.
You know what? All this chemistry has gotten my appetite rumbling, and I smell something good.
It's red cabbage!
Yummy! Kids, did you know that red cabbage is rich in antioxidants and free radicals, which are reactive and uncharged molecules that help prevent cancer?
Eat your veggies, kids. But first, let's do some science. We're going to be talking about something called pH now. Does anybody know what pH is?
pH or PU, because PU, gross, I hate red cabbage.
Well, don't worry, Abby. You'll love red cabbage after this cool experiment.
Ooh, I know what pH is. pH is the measure of concentration of hydrogen ions in a solution. Solutions with low pH have high concentration of hydrogen ions and are called acids. Solutions with high pH have low concentration of hydrogen ions and are called bases.
That's right, Christine. Also, a solution with a pH of 7 is called neutral. Anything with a lower pH is acidic, and anything with a higher pH is basic. Now, if you look here, I have a solution made of boiled red cabbage. Red cabbage contains something called anthocyanin, a chemical that changes color based on the pH of the surrounding solution. In acids, it turns pink, and in bases, it turns green or blue.
Wow, that is cool, but what are these 3 beakers here for?
These are solutions of vinegar, water, and milk of magnesia.
Did you know milk of magnesia is a laxative? It helps you go to the bathroom just like the fiber in red cabbage.
Okay, Christine. Anyway, vinegar is an acid, water is neutral, and milk of magnesia is a base, right?
That's right, Abby. What do you think will happen when I pour the cabbage solution into each beaker?
Huh. I don't know. Let's see.
Alright, so here we've got the vinegar solution.
It's red.
Whoa. Now we have the water solution,
Still blue.
and now we have the milk of magnesia solution.
It turned pink when we added the cabbage solution to the vinegar because it's an acid, and it's turned green when we added to milk of magnesia because it's a base.
That's right, and it stayed blue-purple in the water because water is neutral.
Cabbage-tastic. I love chemistry.
This next experiment is going to be scintillating.
What does scintillating mean, Melissa?
Scintillating means that something is so awesome that it's like giving off sparks. Except this next experiment will actually be giving off sparks.
Wow, what are we going to do next?
We're going to set this dollar bill on fire without actually having the dollar bill itself really burn.
Whoa, is that even possible?
Yes, it is, grown grasshopper. What I have here is a solution of water and rubbing alcohol. I'm going to soak the dollar bill in the solution and then set it on fire.
That's because rubbing alcohol is highly flammable, right?
Yes, it is, Abby. But because there's so much water in the solution, the water will actually vaporize before the dollar bill starts to burn. Do you know why?
Oh, I know why. It's because paper has a higher ignition temperature. It's 451 degrees Fahrenheit, like the book Fahrenheit 451. Water only needs to be heated to 212 degrees Fahrenheit to boil. The water boils first, leaving the dollar bill unburned.
Wow, you're actually smart. You must have eaten a lot of red cabbage during our lunch break. Now, let's try out this experiment.
Whoa, that was so cool. I don't think we can find a cooler experiment than that.
Famous last words. Wait until you see what I have in store.
This next experiment is so cool, it'll make all the ones before it totally irrelevant. Get it? Get it? Irrelevant? Like an elephant? Because this is elephant toothpaste experiment. Get it?
Okay, so what are we doing for this experiment?
Ah, right. So you guys know what yeast is.
Yeah, like it's the stuff that makes bread tasty and squishy and everything.
What a very scientific observation, Mina. But yes, yeast works as what's called a catalyst. Catalysts make chemical reactions happen faster. Usually, yeast helps make oxygen bubbles appear faster. In this experiment, we're going to make that happen with something called hydrogen peroxide.
Oxygen is in the hydrogen peroxide, right? So is yeast going to catalyze the release of oxygen molecules from the hydrogen peroxide?
Exactly. Watch what happens when I add this mixture of yeast and water to the mixture of hydrogen peroxide, dish soap, and food coloring. Whoa! Look at these bubbles everywhere. This is a reaction between dish soap and hydrogen peroxide. The yeast, the catalyst, help make this reaction happen faster.
And wow, it feels so warm all around.
That's because this is called an exothermic reaction. Exothermic reactions are when heat is released in a chemical reaction.
You know, surprisingly, Christine, this experiment really did live up to its expectations. It really did make everything else irrelevant.
Sadly, that's all the time we have for this episode of
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
We'll see you next time. Thank you for watching.
Do you want to build a snowman? Okay, we're restarting this.
There we go. It just looks like she's eating chips.
Until you see what I have in store.
But that was Abby. You're supposed to say that because that was my thing. No, no.
This next experiment is going to be scintillating.
What does scintillating mean? Melissa? Melissa, what does it mean?
Sorry, scintillating means that something is so awesome. It's like it's giving off sparks, just like this next experiment.
Okay, we need this thing to go fast.
Yeah! Fire! Not as clever as this next experiment I'm gonna show you.
Well, don't worry, Abby. You'll love red cabbage after.
That voice crack! Mina, it's all on video. Guys, I had to bring this to you, but I'm not wearing glasses.